not calculating the magnification. Magnification, you know, magnification of first image, because object kept at 2f, image will be formed at 2f on the other side. So I write in the first case, this is first case, we have ready-made formula for refractive index, sine of a plus minimum deviation by 2 sine a by 2. Here it is given that angle of minimum deviation is equal to a. So when you substitute it, you are getting, that is sine a, we have split it as sine a by 2 cos a by 2 by sine a by 2. This is coming to be 2 cos a by 2. JEE Mains answer key published. They deleted the question. I think there was some in the original paper came, I think it was I1 greater than 25 degree. I think so. Very good afternoon, everybody. Today, our JEE discussion paper, January 26, JEE Mains paper, ray optics is the paper. Ray optics is the paper. Okay. Let us come to the first question. Here diagram is given. The two plano-convex lenses of details given. First one, refractive index 1.5, radius of curvature of curved surfaces 15, other is 1.2 and 12 centimeter are kept in contact. And when an object is placed at a distance of 30 centimeter from the combination, the combined one, what will be the magnification produced? So let us treat the first part, first lens, first plano convex lens of refractive index 1.5. We can directly use, even without writing the formula, 1 by f is equal to mu minus 1 into 1 by r1. 1 by r1. Yes. And that is coming to be, focal length of first lens is coming to be, yes, we can find it out. I will find it out here. That better to find out here. 1 by f1 is equal to mu minus 1 is 0.5 into how much? 1 by 15. 1 by 15. Therefore, because plane surface is 15, that comes to be f1 is equal to 15 by 0.5, that is equal to 30 centimeter. Second one, 1 by f2 is equal to, that will be minus, because it is a, it's correct. That will be coming to be, we can again treat it as 0.2 into 1 by 12. That is also a plano convex lens. That comes to be 0.2, that is coming to be, f2 is coming to be 60 centimeter. Okay. Now they are kept in contact. Both are plano convex lenses. Both will behave like a, one is of focal length, and here we have calculated the effective focal length as 1 by f is equal to 1 by f1 plus 1 by f2. We can easily work it out, it as f is equal to f1 f2 divided by f1 plus f2, that is 60 into 30 divided by 90, and that is coming to be 20 centimeter. We got it. Effective focal length is 20 centimeter. Now again I'm going to use, because we know many occasions we have used that for a lens, magnification is given by the formula f divided by f plus u. That will be a convenient formula. Here what we have done, we have calculated v, then v by u, they have calculated what? Magnification. But we can directly calculate m is equal to f divided by f plus u. F is combinations focal length. Combinations focal length is coming to be, we got it as how many? Combinations focal length, we got it as 20 centimeter. Okay, here we got 20 centimeter. Then F is a convex lens, it is 30 divided by, not 30, 20, 20. Combinations focal length is 20. That is 20 divided by 20. While putting the value of u, object is kept at a distance of how many? 30 centimeter in front of the combination. So u shine should be minus 30. So this is coming to be 20. That comes to be minus 2. Magnification is coming to be minus 2. Okay. So we can use relatively easy steps. Okay. First, for the plano convex lens, we have direct formula. What is that? Mu minus 1 into 1 by r. Second one, mu minus 1 into 1 by r. So one is 30 and other is 60. Combination focal length we have quickly calculated as 20. Then object is kept at 30 centimeter. Magnification also we can calculate using this. So answer is minus 2. Okay. Next one, a transparent prism, angle of minimum deviation. So minimum deviations value. So let us go to the explanation, that will be better. Yes, we have ready-made formula for refractive index, sine of a plus minimum deviation by 2 sine a by 2. Here it is given that angle of minimum deviation is equal to a. So when you substitute it, you are getting, that is sine a, we are split it as sine a by 2 cos a by 2 by sine a by 2. This is coming to be 2 cos a by 2. If you are not calculating the numerical value, we have the refractive index coming to be a cos a by 2. But we have to, the options given are, what are the possible values of n? A range of values are given. So we have to calculate it. Now tell me, angle of prism speaking, it's practically speaking, minimum value of angle of prism possible is 0. When angle of prism is 0, A is 0, A by 2 is 0, then refractive index is coming to be 2. So one extent refractive index is 2. Other possibility, A is coming to be 90. If A comes to 90, A by 2 is 45. 2 cos 45 will be root 2. Therefore, minimum value of refractive index possible is root 2. Maximum value of refractive index is possible is what? 2. So your option is 1, root in between root 2 and 2. In between root 2 and 2. We go to the next question. Come on. The convex lens of refractive index 1.5, focal length 1 point, immersed in water. So here I'm going to the explanation, but no need of going for this much calculation. This much calculation. Tell me, when the basic result we are using a lens of refractive index, material refractive index mu 1.5, and immersed in water of, that is mu glass, refractive index of mu water is 4 by 3. We have a basic formula that focal length will increase exactly by 4 times. So we have 3 cases we can remember. One, if a lens is immersed in any transparent medium, focal length will increase. If that transparent medium is water of refractive index 4 by 3, lens material mu g is 1.5. Here we have calculated it. Without calculation, we can say the focal length becomes 18, 4 times. Focal length becomes 4 times, isn't it? Then answer is that question is asked you the difference in focal length. First time focal length is f, second time focal length is 4f, f is 18, first focal length is 18 centimeter, second focal length is 4 into 18, that is coming to be 72 times, or 72 centimeter, or simply we can say the focal length becomes, then change difference in focal length is 54. 54 f2 minus f1 is 54. 54 means 3 times the initial value. So without any calculation we can find it. That, but we have to ensure that lens material is of refractive index 3/2, immersed in water of refractive index 4/3. We can take it as granted that focal length will be increased 4 times. So that itself is sufficient. No need of calculating f1 and f2. Directly we can find that focal length becomes 4 times. Change is 3f. So change is 3 times f, 3 times f. Okay. Answer is alpha is 3. We go to the next question. Magnitudes of power of biconvex lens of refractive index 1.5 and that of plano-concave lens is 1.7. Curvature of the concave lens exactly matching with curvature of the back surface of biconvex lens. Then ratio of the radius of curvature of front and back sides of biconvex lens. Isn't it? Biconvex. First is a biconvex lens. So I'll draw in the next page, in the explanation page, that will be better. Yes, this is the biconvex lens. It is told that the curvature of the plano-convex lens exactly matches with the curvature. So this is the arrangement. So for this lens, R1, R2. For a convex lens, biconvex lens, curvatures are R1 and R2, and plano-concave lens, curvature is R2. And magnitudes of the power, So first one, it is given that power of the convex lens will be 0.5 because refractive index is 1.5. 0.5 into 1 by R1 plus 1 by R2. Okay, this is the power of biconvex lens. And power of that convex lens is mu minus 1 is 0.7 into 1 by R2. And we are equating only the magnitudes. It is a negative sign. This is minus 0.7 into 1 by R2. And we are equating the powers. Power of convex lens and power of plano-concave lens are equal. Powers numerical values. So power of biconvex lens, we got it as 0.5 into 1 by R1 plus 1 by R2. And this one is 0.7 by R2. Then simplifying, we will be getting R1 by R2 is equal to 5/2. Okay. So again, we are using the lens maker formula. For a biconvex lens, we have mu minus 1 is 0.5 into 1 by R1 plus 1 by R2. For a plano-concave lens, it is minus, because it is a concave lens, plano-concave lens, minus 0.7 into 1 by R2. Numerical values, magnitudes are equal, equated it. And we have to rearrange it, simplifying. We have to get the value of R1 by R2. R1 by R2 is coming to be 5/2. That is, ratio of the R1 by R2 is coming to be 5/2. Yes. Answer for the question number 4 is 1. 5:2. Now we go to the next question. Now here P1, P2, P3, P4, P5 recorded. The pair of object distance and image UV pairs are given. Object distance and image distance are given. There are 5 cases: P1, P2, P3, P4 respectively. Then we have to get plus 5 power. So I'm not going to explanation page. I use this. Power is equal to plus 5 means it is a what? Convex lens having a power plus 5D. Isn't it? This means it's one image using same, all the cases power is plus 5 by 2. Then what are the possible values of object distance in image using same convex lens? Look, so it is a convex lens of power point plus 5. So this gives you first information. What is the first information? Focal length is 1 by P, 1 by 0.5. That is 0.2 meter, or focal length is 20 centimeter. That's the first information you make. From the power plus 5 diopter means focal length is plus, because it's a convex lens, not especially mentioning, it is 20 centimeter. Now come, we have to check. And what about 2F? 40 centimeter. Okay. First case, object distance is 25. First case, object distance is 25. U is greater than F. And you know, if U is greater than F, V should be greater than 2F. 2F is what? 40 centimeter. Therefore, V should be more than 80. So, U is greater than F, V is greater than 2F, that is, V is greater than 40 centimeter. V is greater than 40 centimeter. Let us check, is it coming correct? U is greater than F, 25, correct? And V is greater than 40 centimeter. This is a possible option. Case 2, let us check. U 30, U is greater than F because F is this thing. Therefore, V should be again greater than 2F. Here, what is the value of V is given to be 62. Again, it is correct. V is more than 40 centimeter. V is 60 centimeter, greater than 40. So, this is correct possibility. Third option, U is greater than F because U is what? 35, greater than F. Therefore, V should be greater than 2F, isn't it? So, V should be greater than 40. V is greater than 2F, or V should be greater than 40 centimeter. But here, V is given to be 37 centimeter. So, the case P3 is not possible. Case P3 is, because in case P3, object distance is more than 2F because it is 35 centimeter, F is 20 centimeter more than F. Image should be more than 2F. It should be more than 40 centimeter. So this case is not possible. Then we can easily go through it. What about this case 4, P4? Here U is greater than 2F. U is greater than 2F. V should be greater than F. Yes, or V should be greater than 20 centimeter. Let us check. Yes, this is 45 and greater than F. U is greater than 40. Therefore, V is greater than 20. Is correct. V is greater than 20. This is the correct option. The second case, again, fifth case. In fifth case, U is greater than 2F because 2F is 40. Here it is given 50 centimeter. Therefore, V should be greater than F, or V should be greater than 20. Here it is given, V is given to be 32. So this is matching. So according to the given informations of U and V, P1 case possible, P2 case possible, P4 case possible, P5 case possible, P3 case not possible. I explain once again P3 case. In P3 case, object distance is given to be 30. That is more than F, more than 20. Therefore, according to the image formation, we should be greater than 2f. We should be more than 2f. We should be more than 40 centimeter, but it is less than 40 centimeter. So this case is not possible. So what is the answer? That reading P3 cannot be or incorrect. Reading P3 cannot be possible. It is incorrect. So our option is 4. Our option is 4. Next, we are going to the fifth question. 5%. So, okay, we have done it. Explanation is over. We go to the next question. Distance between object and 3 times magnified image is 40 centimeter. The focal length of the mirror used is. Let us go to explanation quickly. Here, magnification is coming to be -3. Okay, because real image, magnified image. So here it is given that magnitude of V minus magnitude of U. Numerical value only. Distance, we have to take numerical values. So magnitude of V minus magnitude of U is magnitude of 3U minus U, that is 2U. And the distance is coming to be 40 centimeter, that U is coming to be 20 centimeter. Therefore, object distance is coming to be 20 centimeter. Okay. Now, we have to calculate what? We have to calculate the focal length of the lens. Again, I told you this is a mirror. For a mirror, the magnification formula is given by f divided by f minus u. Lens it is f divided by f plus u. Here it is f divided by f minus u. Magnification is given to be magnification is given to be magnification is given to be -3 real image. Yes, we have to calculate the focal length. So I don't give the sign of focal length. F minus U is given to be how many? 20 centimeter. Minus of minus 20. And we are getting -3 is equal to F divided by F plus 20. Multiplying -3F minus 60 is equal to F. So that comes to be 4F is equal to -60. F is equal to -15. F is equal to -15. So your answer is -15. Question number 6. Answer is -15. That is option 2. Option 2. We go to the next question. Tell me, microscope tube length is 10 centimeter and convex lens are arranged with focal length of 2 centimeter and 5 centimeter. Magnified, the magnification of the system or the microscope is given to be 5 to the power of k. We have to calculate the values. It's a very simple question. Explanation is very clearly given. We have the ready-made formula for L into D divided by FO into FE. L is length of microscope, D is least distance of distinct vision, that is 25. When you work it out, this is coming to be 5 into 5, that is coming to be 5 square. Or here it is 5 square is equal to 5 to the power of k. Value of k is coming to be 2. Value of k is coming to be 2. So your answer is coming to be 4. Answer is coming to be 4. So we go to the next question. Come on. The exit surface of a prism of refractive index n is coated with a material having refractive index n by 2. When this prism is set for minimum angle of deviation, exactly it meets the condition for critical angle. Yes. So let us better to draw a diagram. Yes. This is being coated with a material of refractive index. It is coated with a material of refractive index n by 2. And here it is n. You know, a light ray, yes. Tell me, this is R1, this is R2. So first of all, since it is undergoing the minimum deviation condition, we can find R1 is equal to R2 is equal to A by 2. The first condition we have written. R1 is equal to R2 is equal to A by 2. Then second condition, it meets the condition for critical angle, meets the condition for the critical angle. So we can find that here this is 90 degree, this angle of refraction is 90 degree. So we can using the condition that coming from a medium n into sine r2 is equal to n into, because here it is angle of refraction is 90, here angle of n1 mu1 is equal to n2 mu2, n into sine r2 is equal to n by 2 into sine 90. When you solve it out, sine r2 is coming to be half, or r2 is coming to be 30 degree. Therefore, we have to calculate the angle of prism. Angle of prism is r1 is equal to r2 is equal to a by 2. That is a by 2 is 30 degree, or a is equal to 30 into 2, 60 degree. So answer for the question is 60 degree. Answer option is 3. Go to the next question. Size of an image of an object found by thin equal to an object placed at two different positions of 8 centimeter and 25 centimeter from the lens. Focal length of the lens is two different position. One is a magnified image and other is a diminished image, isn't it? Okay, so tell me the size of the images, size of the images. So here, what is the size of the image or magnifications? F divided by F plus U. That is coming to be F divided by F minus A. For the second case, F divided by F minus 4. But this is our image, real image, this is minus, this is a virtual image plus. And now simplifying, f get cancelled, f minus 24 is equal to minus of minus f by 2, and we are getting f is equal to 16 centimeter. F is coming to be 16 centimeter. So in question number 9, the gap missing is 16 centimeter. Simple problem. We are here, magnifications, magnitudes are equal, but when you equate it, if you cannot equate the magnitudes, if magnitudes are equating, there is no meaning in the expression. So we have to expect real situation. This is a virtual image f divided by f minus 8, because object is kept within focal length. This is object is kept beyond f. Therefore, this is a real image, magnification is minus. So I equate for the formula of magnification. Then numerators are equal, so denominators can be equated. F minus 24 is minus of f minus 8, then we'll be getting the answer. We go to the next question. Okay, now prism of 75 degree and refractive index root 3 is coated with a film of refractive index 1.5 at the back surface to have total internal reflection at the back x surface, then incident angle must be. Let us go to the, so what were things given to you? Refractive index mu, angle of prism 75 degree, back side is coated with the material of refractive index 1.5, and total internal reflection takes place there. So let us go to the explanation. This is, tell me at the back surface, and these informations are also given to you. At the total internal reflection at the back surface, their angle of refraction at second surface R2 must be greater than or equal to critical angle. R2 is greater than sine inverse mu film by mu prism. That is the, because light coming not from air to the film, coming from prism material to film material. So R2 should be greater than sine inverse mu film, and that you work it out. This is coming to be greater than or equal to 60 degree. Better I draw the diagram. This is 75 degree. This undergoes total internal reflection, isn't it? So this is greater than, this is R2 is greater than or equal to critical angle. This is R1. Tell me, R2 we got how many? 60 degree. Therefore, R1 plus R2 is how much? A. Therefore, R1 is A minus R2. A is 75 degree. 75 minus 60, that is how many? 15 degree. But we have to put a condition. What is the condition we are putting? R2 is greater than what? That's better. R2 is greater than 60 degree. And you know what is R1? R1 is A minus R2. If R2 is greater than 60 degree, R1 will be less than what? 15 degree. If R2 is 60 degree, R1 will be 15. But here it is given that for total reflection to happen, R2 should be greater than 60 degree. Therefore, R1 should be less than 50 degree. Then here we have to calculate the angle of incidence. Okay. So angle of incidence we can calculate. Here it is given that uh, sine I is equal to root 3 sine R1, and that is coming to be root 3 is 1.C3, that is 0.58. This is coming to be 0.5. Therefore, sine I is coming to be 0.44, nearly 0.44. Isn't it? Okay. And sine I is 0.44. I will be given to be sine inverse. I is given to be sine inverse 0.44. That value is also given to here, 0.43 or 44. Nearly this is coming to be 25 degree or 26 degree. Okay. So now look here, mu is sin I by sin R. In the first surface, mu is sin I by sin R1. So if R1 is less than 15, automatically I1 should be less than, how much I1 I got? 25 degree. I1 should be 25 or 26 degree. Okay. And the option in the JEE Mains answer key published, they deleted the question. I think there was some in the original paper came, I think it was I1 greater than 25 degree. I think so. I'm not sure about it. I think so. So that's why when the uh, key correction came, that question was deleted. But now, according to the option given to your question paper, now I go back to the question paper. According to the option given to the question paper, here options are less than 26 degree or less than 25 degree. So here, accordingly, option 3 is correct. But in the question paper at the time of examination on January, this paper, this option was, I think, wrongly printed. That's why they have deleted it. Okay. Madam, ക്ലാസ്സിലാണ് madam. Yes. Now, a thin prism of angle 5 degree, refractive index 1.72 is combined with another prism of refractive index 1.9 to produce dispersion without deviation. So very simple question. Explanation is very clearly here produces dispersion without deviation. Therefore, simple calculation, the deviations formula is A into mu minus 1. Deviation of first prism is equal to deviation of second prism. Here, A1 given, mu1 given, mu2 given, A2 you have to calculate. So, using this values of A1, mu1, mu2, we are getting A2 is equal to 4 degree. We are getting A2 is equal to 4 degree. Very simple, direct substitution. Deviation due to mirror number 1, sorry, present number 1 is equal to deviation due to the present number 2 without deviation. So, deviations we equated. We go to the next question. Consider a light traveling from a medium A to medium B in a plane reference. The light undergoes total internal reflection, travel from medium A to B. The speed of light in medium A to medium B is 2.4 respectively. Then value of the critical angle, You know, Here, speed in medium A, VA is coming to be 2.4 into 10 to the power of 8. VB is coming to be 2.7 into 10 to the power of 8. Therefore, B is a rarer medium. Speed of wave is more, speed of light is more. Therefore, B is a rarer medium. B is a rarer medium. Yes, B is a rarer medium. Okay, first information. Now, here it is given that light coming from A is a denser medium. Light coming from A to B, light coming from denser to rarer medium. First condition for total reflection has taken place. Now, here, what you have to calculate? Critical angle we have to calculate. So, sine of critical angle is given by 1 by normal mu. What is normal mu? Light goes from rarer to denser. Light going from rarer to denser, isn't it? Light going from rarer to denser. So what will be that? That will be refractive index of A mu B, because we have to consider normal mu, light going from rarer to denser medium. So A is a denser medium, B is a rarer medium, sorry. We have to write it as what? B mu A. And we know the BA mu A is equal to mu A by mu B. Therefore, sin C is equal to 1 by mu A by mu B. That comes to be mu B by what? Mu A. Mu B by mu A. Oh, is equal to mu B, mu A by mu B. The sin C is equal to mu B by mu A. Refractive index of mu B. Refractive index of mu B will be what? Velocity in air divided by velocity in B divided by velocity in air divided by velocity in A. That comes to be velocity in air get cancelled, velocity in A in velocity in B. That is sin C, sin C. And A is a denser medium where velocity is less. And what is that less velocity? 2.4 into 10 to the power of 8. Similarly, divided by velocity in B, rarer medium, speed is more. Speed is coming to be 2.7 into 10 to the power of 8. This is coming to be 2.4 by 2.7. That comes to be 8. This is 3. No. This is 8 by 9. Isn't it? Therefore, we are getting sin C is coming to be 8 by 9. Now look into the option, whether any answer coming. Sin inverse 9 by 8 is there, but that is not possible. We want sin 8 by 9. So we have to look into other options. So let us find out other angles. We can make, let us mark C here. This is C. C is opposite side by hypotenuse. Opposite side by hypotenuse. So opposite side is 8, hypotenuse is 9. This will be root of 9 square. 9 square is 81 minus 64. That is root of 17. So one option is that, what about tan C? Tan C will be equal to 8 by root 7. That is possible. We can make tan C is equal to 8 by root 17, or C is equal to tan inverse 8 by root 17. That option is there, isn't it? So first calculation, first attempt, we are getting what value? We are getting the value sin C is equal to 8 by 9. But that value is not over there. So we try for other angles. We have to make a right angle triangle. From that we find out tan C or cos C, whatever you require. Your tan C is matching, so you'll be getting its answer is coming to be 1. Next one, so it's explanations I given separately. Now come on, wavelength of light in passing through water is 540 nanometer. Refractive index of water is 4/3. Wavelength of same light when passing through, again, I'll give an easy explanation. Let us go to the explanation part whether any. Yes, it is very simple. Wavelength in a medium into mu m is equal to wavelength in water into mu w. This is it. So lambda in medium into 3/2 is equal to wavelength in air is given to be 540. Wavelength in water. Wavelength in passing through water is 540. What for 540 into 4/3, and other is what? Light while passing through water is 540. Refractive index of water is 4/3. Wavelength of the same light when passing through another medium, that's 3/2. So solving it, we'll be getting what? Lambda m is equal to 480 meter. Which is easy question, direct question. Okay. Let us go to the other one. A parallax method determine focal length of a concave mirror. So in parallax method, what we do? We keep an object, either a pin or a light source. We get a real image formed on a screen. So here object and images are real image you are getting. Real image you are getting. For getting a real image, object should be placed beyond focus. Once again, this is a case of image formation by parallax method by a concave mirror. For a concave mirror to give a real image, because we are getting images formed on a screen in parallax method. Images formed on a screen in parallax method, it should be real image. For real images to be formed, focal length should be more than, object distance should be more than focal length. Therefore, object should be placed at any point beyond the focus. So answer is 3. Let us go to the next question. So explanation is given. I go to the next question. Tell me, a thin convex lens of focal length 5 centimeter and thin concave lens of focal length 4 centimeter are combined together without it. So yes, first case, 2 lenses are kept in contact. One is a convex lens of focal length, other is a concave lens of focal length. Yes. This is f1 5 centimeter. This is f2 minus 4 centimeter. Now, in first case, you know, an object is kept placed at 10 centimeter before the convex lens, and it is easy for you because focal length is 5 centimeter. We are keeping the object at 10 centimeter. So image will be formed. First case, image will be formed at this is object. Image will be formed. This is 10 centimeter means 2f. Image will be formed 2f on other side, 10 centimeter. Okay, we got it. Isn't it? Then when the image is placed 6 centimeter before the convex lens, keeping the position of, so here, tell me, M1 is the magnification of what? The combination of lenses. So we can consider like that. The convex lens forms an intermediate image, and that intermediate image is 10 centimeter. That is going to form an object for the concave lens and forms the final image. Final image. So tell me, I am not calculating the magnification. Magnification, you know, magnification of first image, because object kept at 2f, image will be formed at 2f on the other side. So I write in the first case, this is first case, first case, when the two lenses were kept in contact, object is kept at 10 centimeter, that is at the 2f of convex lens. Image will be formed on the 2x on the other side. So magnification will be -1. Okay. So we got it. Then, second case, second lens, that is, I told you, magnification in the first case, M11. That is in the first case due to the first lens. First case due to the first lens is M11. Then M12. M12, we can calculate what? First case due to the second lens, where the magnifications you can directly get f2 divided by f2 plus u. Look, f2 is what? F2 is focal length of the concave lens, that is -4, divided by -4. And here the intermediate image I acts as an object for what? The second lens. So second lens object distance is what? 10 centimeter behind the lens. So we can take it as what? +10. We can write it as +10. So magnification in second case will be how much? -4 divided by +6. Isn't it? That comes to be minus 6. So -2/3. -2/3. Therefore, tell me, so we got the magnification as so. Let us go to the other one. We have to calculate. Understand the gap of 1 centimeter. Okay. Second case, M12 is equal to F2 divided by F2 plus U. F2 is -4. Then F2 plus -4 plus 10. Because intermediate image is formed at centimeter. This is coming to be 2/3. Therefore, in the first case, combinations effective magnification is M12, its numerical value we want. M12 into M11 into M12. That comes to be -1 into -2/3. That is coming to be 2/3. Now, in the second case, again, what arrangement they made is that concave lens is moved through a distance 1 centimeter. Other things remaining same. Isn't it? Object is kept here at 10 centimeter. This is F1, 5 centimeter. This is F2. And due to the first one, intermediate image will be formed. In the first case, M1. Here I will write. Okay, here I will write. Second case, magnification due to first lens, that I write M1 in second case, M12. Again, object is kept at 2f, image will be formed at 2f, therefore it will be -1 as in the previous case. Then for second case, it is 1 centimeter advance. This is 1 centimeter advance. Now distance from intermediate image to the lens, this is coming to be 9 centimeter only. 9 centimeter. First case, they were in contact. Intermediate image was formed at I at 10 centimeter. Distance from intermediate image to the concave lens was 10 centimeter. I calculated the magnification using this formula. I got it as -2/3 and overall magnification is 2/3. Now, in second case, I am calculating the magnification due to the second lens in second case. will be minus f divided by f2 plus 1, that is minus 4 divided by minus 4 plus 9, that comes to be minus 4 divided by 5, minus 4 divided by 5, isn't it? Minus 4 divided by 5. Okay, yes. Then combinations focal length in second case, minus 4 divided by minus 4 plus 9, and that comes to be, this is 5 minus 4 by 9. Then M22 will be minus 1 into minus 4 by 5, that comes to be 4 by 5. So combinations, first case combinations magnifications value, that is coming to be 2 by 3. Second case magnifications value coming to be how much? 4 by 5. Is it coming to be 4 by 5? Then ratio will be M1 by M2 will be 2 by 3 into 5 by 4. That is coming to be 5:6. 5:6. Question number 15. The answer is coming to be 5:6. Option number 1 is the correct answer. Okay. Yes. So some lengthy arrangement is that, but we can simplify the calculations. Okay. Because as far as first case and second case is there, intermediate image is formed at same location, same image, no change for that. So it is formed at a distance 10 centimeter from the combination, from the convex lens, and magnification is minus 1 because it is a image formed at 2f. Then we have to calculate magnification in first case and second case, and that we got 2 by 3 and 4 by 5. Then we will be getting the answer. We go to the next question. Come on. The answer is 5/6. Come on. A parallel beam of light traveling in air, refractive index 1, incident on a convex spherical glass surface of radius of curvature 50 centimeter, refractive index of glass is 1.5. Rays converge at a point distance x from the center. Okay, yes. Let us draw the diagram. Yes, a light beam traveling from air is incident on a convex spherical glass surface, convex surface. Yes, this is O, but the object is kept parallel beam. Yes, and it is converging to a point here. Okay, this is the center of curvature. This is the image. We have to calculate the distance. The rays converge at a point distant x from the center of curvature. So we want to calculate distance from R to I, that is our x. Distance R to 1 is x. So we have to calculate what? The value of x. Now, refraction at a single surface, mu2 by v minus mu1 by u, or mu2 minus mu1, substituting for that, object is infinity, therefore u is at infinity. Working out, we are getting v is coming to be 150 centimeter. V is from O to I. O to I is 150 centimeter. But we know that radius of curvature is given to be how many centimeter? 50 centimeter. This is coming to be 50 centimeter. Therefore, we want x. X is equal to OI minus OR. OX we got it as 150 centimeter. OI we got it as 50 centimeter. Therefore, x is coming to be 100 centimeter. X is coming to be 100 centimeter. In question number 16, your answer is coming to be 100 centimeter. Okay, come on. We go to the next question. Equilateral prism of refractive index √2 ray of light is incident on its one of the surface. Critical angle I, and emerge rays found to graze along the surface. Then angle of refraction of the incident ray is close to, referent ray is close to. So refracting this √2 roughly incident at one of the surface at certain angle I, and it is going grazing from second surface. Okay. Yes, it is incident here. Then it goes like that. So come on. Here the angle of incidence I, we have to calculate the angle of refraction. Here we have to calculate it. This is I, this is R1, this is R2. Refractive index is root 2. This is going, this will be 90 degree. This gives you R2 is equal to critical angle is equal to 1 by mu, that is coming to be 1 by root 2. Therefore, R2 is C is coming to be, R2 is coming to be C is equal to 45 degree. Isn't it? Sin C, not C. R2 is equal to sin C is equal to 1 by mu is equal to 1 by root 2. Therefore, R2 is equal to C is equal to 40 degree. Now, this is an equilateral prism. Therefore, this is what? 60 degree, 60 degree. Therefore, we know R1 plus R2 is equal to what? 60 degree. R1 plus R2 is equal to 60 degree. Therefore, R1 will be is equal to 60 minus 45. That is, R1 is coming to be 15 degree. Isn't it? R1 is coming to be 15 degree. Now, we have to calculate what the angle of refraction, that is R1. Angle of refraction at first surface is R1. So it's very clearly R1 is equal to what? 50 degree. Very simple combination. Light ray coming here, going like that. Second surface, it undergoes grazing. That means this is 90 degree. So this is critical angle. Critical angle, we got it as what? 45 degree. Critical angle is your R2. And for prism, R1 plus R2 is equal to A. Here A is 60 degree. R1 plus R2 is 60 degree. R1 is equal to 60 minus 45. That is 15 degree. So easy calculation. We go to the next question. Okay. Now, tell me here, I'll do here, I'm not going to the explanations, I'm not clear in explanations. Look, I'll draw it in a better manner. It is told that here I draw the normal. Here I draw the normal. This is given to be 45 degree. This is given to be theta. If refractive index of the material of the prism is root 2, and here emerged ray is grazing, So this angle is grazing along second surface. This is 90 degree. As in the previous problem, this is coming to be 45 degree. Because critical angle is 45 degree, R2 is 45 degree. Come on. Now, it is given that incident ray is parallel to the base. This is the base, parallel to the base. So using law and transverse angle, this will be 45. So this will be 45 degree. This is normal. This will be 45 degree. This will be 45 degree. Because these two angles are alternate angles. Therefore, this is 45. This will be 45. This will be 45. Therefore, this is normal. This will be 45 degree. And this is R1. This is R1. Now tell me, at the first surface, mu is equal to root 2 is equal to sine I1 divided by sine 45. It's a very common thing. We can get I1 is 30 degree. I1 is the, this is 30 degree. Sorry, I1, not I1. R1 is 30 degree. Sorry, when I made a mistake. Mu is equal to root 2 is equal to sine I divided by sine R1. Sine I is sine 45, that is 1 by root 2. Then this is sine R1, and working, we will be getting R1 is equal to 30 degree. Now again, third or fourth time we are using angle of prism is equal to R1 plus R2. That is coming to be angle of prism is equal to R1 is how much you got it? 30 degree plus R2 is 45 degree. This is coming to be 75 degree. So angle of prism is coming to be 75 degree. Is coming to be 75 degree. Now, tell me, in a triangle, sum of all the three interior angles are how much? 180 degree. What are the angles? 45 degree plus angle of prism is 75 degree plus theta. That comes to be 180 degree. Therefore, theta is coming to be 180 minus 45 plus 75. That comes to be, theta is coming to be 180 minus 120. That comes to be 60 degree. So, using the same concept, R1 plus R2 is to A, and critical angle is equal to the angle of refraction. This idea is coming in 3-4 problems it has come. So many things repeated that manner. Okay, your answer is coming to be fourth, and fourth is the correct option here. Now we go to the next question. A collimated beam of light of diameter 2 millimeter is propagating along x-axis. Diameter of the lens. The beam is required to expand in a collimated beam of diameter 14 millimeter using a system of two convex lenses. The first lens has a focal length of 40 centimeter, then focal length of the second lens. Okay. Now, come on, I'll draw that. Parallel beam of light is coming, and collimated beam is a parallel beam, and emerged beam is also collimated. So I can draw the diagram. A parallel beam of light rays are coming. Okay. Yes. A parallel beam of light rays are coming, and we know they will be converging to their focus. And again, they are forming on the second lens. From second lens, they go parallel. Coming as a collimated beam, going as a collimated beam. Okay. So when light rays are coming parallel, they will be meeting at their focus. That is focus of first lens. And for the light ray to go parallel, according to the definition, this is the second focus of first lens. It becomes first focus of the second lens. So light rays will go parallel, or we say use the word collimated beam. So this distance is coming to be F1, and F1 and F2 is coinciding. F1 is coming to be how much? Using two convex first lens of focal length, this is 40 centimeter. Okay, 40 millimeter. Okay, 40 millimeter. Now, this is also the focus of first focus of second lens. So this distance should be equal to focal length of the second lens. You have to calculate the focal length of second lens, F2. Now tell me, if this angle is alpha, this is alpha. Okay, vertically opposite. Or this is also alpha. This is also alpha. For first triangle, tell me, for first triangle, this is, you have to actually, you have to draw it in the, here we have to draw it. This we have to draw it. Actually, we have to draw it here. So diameter is how much? 2 millimeter. So this is coming to be 1 millimeter. Here diameter is 14 millimeter. So this is coming to be what? 7 millimeter. Okay. Yes. What about here? Tan alpha. Tan alpha is equal to 1 divided by how much? 40. This is 40. Second case, tan alpha is equal to 7 divided by F2. First case, tan alpha is 1 divided by 40 because this is 40, this is 1 millimeter. Second case, F2 we have to calculate, this is 7 millimeter. Now, equating it, 1 by 40 is equal to 7 by F2. Therefore, F2 is equal to 7 into 40, that is equal to 280 millimeter. Your answer is 280 millimeter. Answer is coming to be, let us check the correct in the answer sheet given. Yes, it is 280 millimeters, correctly given. Now we go to the last question. Microscope focal length having f4 is 2 centimeter, eye lens having focal length 4 centimeter, tube length is 32 centimeter, magnification produced by the microscope. The easiest problem of this question paper, direct problem, but 2 or 3 questions have come from microscope. We have direct formula for magnifying power, L by FO into D by FE. L is length of the tube that is given to be 32, FO is 2, D is 25 centimeter. This is 4. This is coming to be 16 into 6.25. That is coming to be 100. Okay. Now, all the questions. Okay. Some questions have given repetition 2-3 times. So take care of that questions. Okay. Bye.